Okay, section 11.2, Algebra of Matrices, part 4. We're continuing on with matrix multiplication. With matrix multiplication, remember it's a row of the first matrix, column of the second matrix, so those middle row by column dimensions have to match. Once they match, then we can perform the matrix multiplication. Let's look at problem 28. We're going to multiply in this order, D times H. Okay, matrix D is one row with two columns. Matrix H is two rows, two columns. Because these matrices dimensions match, we can go ahead with the multiplication, and our multiplication result is going to be a 1 by 2 matrix. Let's see how that works. We grab our calculator, and I have already put in the matrices to save us a little bit of time. So let's double check. Matrix D is that 7, 3. Matrix H is our 2 by 2. Okay, so already in there. So then we're going to take, and I'm just using up arrow, matrix D to select, times matrix H to select. There's our solution, a 1 by 2, 27, 4 matrix answer. The order that we multiply matrices does matter. Here we were multiplying D times H. Let's see what happens when we take H and multiply it by D. Okay, so looking at H, we do have a 2 by 2 matrix. Looking at D, D is still a 1 by 2 matrix. Notice that these two numbers on the inside do not match. So we stop here, and we're going to say matrix multiplication is not possible. So the order that we multiply matrices matters. Let's see what our calculator tells us. Okay, so we're going to select H. We're going to multiply that by D. And it says dimension mismatch, and that's again because these middle numbers don't match up. Now our answer is never dimension mismatch. Our answer is because these inside numbers aren't equal, the matrix multiplication is not possible. We can't match up the row of the first matrix with the column of the second matrix in order to multiply and add. Okay, let's look at our next problem, number 30. We're going to take matrix B. So we have matrix B, which is a 2 by 3, with matrix C. And before we do that, let's see if this multiplication is even possible. Okay, so we're going to work with matrix B and matrix C. Okay, matrix B is 2 rows with 3 columns. Matrix C is 2 rows with 3 columns. We see that these two inside entries don't match, so we're going to just stop right there. We're going to say multiplication not possible. Okay, here we're going to take matrix B and matrix F. B is a 2 by 3. F is a 3 by 3. We see that these two inside numbers match up. Because those two inside numbers match up, that tells us the matrix multiplication is possible, and we're going to end up with a 2 by 3 matrix. Okay, so let's get those multiplied together. B times F. Okay, so here's matrix B. Let's look at matrix F. Okay, so I already had those put in, and now we're going to take B times F, and we should get a 2 by 3 answer, and there it is. There's our 2 by 3 result. Now, when we look at matrix F is a special matrix. We have ones along the diagonal, 0 above and below. And so what this is called is an identity matrix. So we're going to say I3. 3 by 3. Ones along the diagonal, zeros everywhere else. Identity matrices we're going to learn are square matrices. And when we look at identity matrix, an identity matrix acts like 1 when we multiply. So notice that B times F gave us B. F is a special matrix with that ones along the diagonal. It's called an identity matrix. An identity matrix works like 1 when we multiply. B times 1 would give us B. Okay, let's continue on. We have B times B. B is a 2 by 3. B is a 2 by 3. These numbers don't match up, so this matrix multiplication is not possible. Okay, we have F times F. F is a 3 by 3. F is a 3 by 3. These numbers match up so that we know we can multiply these two together, and our answer is going to be a 3 by 3 matrix, and we probably already know what it is. Remember, this acts like 1 because F is a special matrix, the identity matrix. What happens if we take 1 times 1? We're going to get 1. So here we're going to end up with just F. We'll put that in our calculator, and that's going to come out with 1, 0, 0, 0, 1, 0, 0, 0, 1. I'll leave that to you to verify, but I know that that's correct.